Here we go with another problem. So this is question 4 from the 2014 AB International Exam. The continuous function f is defined on the interval -5 less than or equal to x less than or equal to 8. The graph of f consists of 4 line segments as shown in the figure above. Let g be the function g of x is 2x plus the definite integral from -2 to x of f of t dt. Okay? In part A, we're asked to find g of 0 and g of -5. So number one, let's make sure we're clear. This up here is the graph of f, and then g of x is 2x plus the integral from -2 to x of f of t dt. I just want to write that at the top so we can come back to it. Part A says to find g of 0. Well, how am I going to do that? I'm going to go over to g, and everywhere I see an x, I'm going to replace that with 0. So 2 times 0 plus the integral from -2 to 0 of f of t dt. Of course, -2 times 0 is 0, so we just get the integral from -2 to 0 of f of t dt. Well, how do I find the definite integral? I don't have an equation for the function. I need to remember that the integral from -2 to 0 means area. And if I look on my graph, starting at x equals -2, going all the way over to 0, what I have is a trapezoid. And we're going to find the area of that trapezoid using the formula 1/2, the sum of the bases. The bases are always parallel to one another. That has a height of 2. This has a height of 1 times that perpendicular distance between those, which is 2. Because this is the free response, I can stop right here, or you can go further, and your best final answer is going to be 3, but there's really no need to do that because it's the free response. Also in part A, we're asked to find g of -5. Let's do the same thing. 2 times -5 plus the integral from -2 to -5 of f of t dt. Well, 2 times -5 is -10. Now, I'm supposed to integrate from -2 to -5. Normally, when we're dealing with definite integrals, the smaller number is your lower limit of integration, and the larger number is the upper limit of integration. You can switch these if you need to, and so you can integrate from -5 to -2 f of t dt, but now you need to keep in mind that because you switch the limits of integration, you're introducing a negative sign into the problem. Okay, well now we need to find the area from -5 to -2. If I look at the graph and I start over here at x equals -5 and I end over here at x equals -2, I've got two different triangles to consider. This one is below the x-axis, so it has a negative area. This guy is above the x-axis, so we have a positive area. To find the area for the triangle below the x-axis, we've got -10 minus. Area of a triangle is 1/2 the base. That base has a width of 2. The height, what's that point? That point is -5, -4. So that's a height of 4. And I need to keep in mind that that's below the x-axis, so there's a negative that I've got to include here. Sorry if that's a little bit messy. Now I need to add on the area from x equals -3 to x equals -2. That's another triangle, 1/2. The base is 1, the height is 2. And again, this is the free response part of the test, so there's no need to simplify if you don't want to, but let's get a little bit of practice anyway. -10 minus 2 times 4 is 8. Half of that is 4. You've got -4. 2 times 1 is 2, times 1/2 is going to be 1. So where are we? We've got -10 minus -3, which is -10 plus 3, which is -7. You have what we like to call a safe stop right here when you first get to all numerical values. There's no need to simplify, and quite honestly, all you're doing at this point is wasting time and you're running the risk of losing a point. So 1 point here, 1 point for correctly evaluating g of 0. In total, 2 points for part A. All right, let's look at part B. And I'm going to fold the paper up a little bit again so I can see part B. In part B, now we need to find the values of g double prime of 4 and g double prime of negative 2. Well, what do we know? We were told earlier that g of x is 2x plus the integral from negative 2 to x of f of t dt. If we're going to find g double prime of x, first of all, we need to find g prime. G prime is the derivative of 2x plus the integral from negative 2 to x of f of t dt. We can take the derivative of each of these terms separately. The derivative of 2x is 2, plus now we need to take the derivative of the integral, negative 2 to x of f of t dt. This part over here is known as your second fundamental theorem of calculus. The second FTC says that if you're taking the derivative of the integral of a function from a constant to a variable, that the derivative is just going to be the original function evaluated at the new variable. What did I just say? It means that your final answer is 2, the 2 from before, plus f of x. This is g prime of x. Now, remember, we're trying to find g double prime of 4 and g double prime of negative 2. G double prime means we need to find one more derivative. We need to find the derivative of 2 plus f of x, which is just f prime. G double prime of 4 is f prime of 4. F prime of 4 is the slope of the tangent line to the graph of f at x equals 4. If we go and we look at the graph, I would want to see, where's x equals 4? Well, 1, 2, 3, 4. Oh, bummer. X equals 4 is a point, there is of course a point on the graph of f, but I can't find that slope easily just at this point. But I do want to remember that this is a point on a line. And so the slope of the line that contains the point x equals 4 is the same as the slope of the tangent line at x equals 4. I have the point 2, 3. Looking at the graph, I can see that my graph of f intersects the point 5, 0. So what's the slope? The slope is going to be, let me look at those points again, the change in y, so 3 minus 0, divided by the change in x. That's going to be 3 over negative 3, which is negative 1. Sorry, that was off the page. G double prime of negative 2 is the same as f prime of negative 2. Well, let's look at that graph again. F prime of negative 2. We look at the graph. We find x equals negative 2. Here we are. The slope at this point, now let's be careful here. The slope of the tangent line at this point, this is a cusp point. The slope of the tangent line to the left of negative 2 is not the same as the slope of the tangent line to the right of negative 2. Because of that, g double prime of negative 2, which is the same as f prime of negative 2, does not exist because f has a cusp point at x equals negative 2. In terms of how points were awarded, you were given 1 point for establishing the relationship that g prime of x is equal to 2 plus f of x. another point for determining that g double prime of 4 is -1, and then finally for realizing that g double prime of -2 does not exist. In total, this is a 3-point question. All right, not bad. Let's keep going. In part C, we're asked the question, on what intervals is the graph of g concave down? Well, wait a minute. What has to be true about g? If g is concave down, let's think about this for a second. This means that g prime is decreasing. That also means that g double prime is negative. G is concave down, g prime is decreasing, g double prime is negative. Well, which one of these is going to be helpful? We know that g prime is 2 plus f of x, and I see the graph of f of x up here. So g prime is 2 plus f of x. This 2 is just a vertical shift of the graph of f of x. What that means is whatever the graph of f of x is doing, the graph of g prime just says take this graph and shift it up 2 spaces. So wherever f is decreasing, g prime will also be decreasing. Wherever f is increasing, g prime will also be increasing. So where is g prime decreasing? I can see from the graph that we are decreasing from -2 until we get to 0. And then we start decreasing again at x equals 2, and we decrease all the way until 8. This is worth only 1 point. You get 1 point for identifying the intervals and for explaining how you know that that's true. Okay, that's part C. Last one, part D. Let's fold that paper again. In part D, we're told now that the function h, this is a new function, h of x is equal to g of x cubed plus 1. Now, if you're in my calculus class, you know I make a big deal about the way that we pronounce things because that's awesome. There's also going to be a clue. H is g of x cubed plus 1. That verbal of is an indication that when I use the derivative, I'm going to use the chain rule. So to find h prime of 1, first we find h prime of x. You find the derivative of the function. That's going to be g prime of x cubed plus 1 times the derivative of the inside function, which is 3x squared. To find h prime of 1, plug in 1 everywhere. G prime of 1 cubed plus 1 times 3 times 1 squared. This is g prime of 2 times 3. Well, what the heck is g prime of 2? Remember earlier we identified that g prime is 2 plus f of x. So g prime of 2 is the same as 2 plus f of 2, and then we multiply that by 3. To figure out the value of f of 2, we go to the graph. I see that at x equals 2, the y value is 3. And so we've got 2 plus 3 times 3. That's 5 times 3, which should be 15. In terms of points, you were awarded 2 points for correctly finding the derivative, and then a third point for evaluating the derivative at 1. Now, where's the safe stop here? You could stop at the 2 plus 3 times 3 because those are all numbers. You cannot stop here at 2 plus f of 2 times 3 because f of 2 isn't a number yet. You would have to go to the graph and evaluate this and say f of 2 is 3 before you can finally stop. All right, in total, part D is worth 3 points. Not bad. I would hope that for calculus students, Parts A and B are not too bad. Part D is the kind of question I would expect really everybody is going to get correct. It's just the application of the chain rule. And maybe part C is a little bit tricky. All right, nice job.